Hey guys, welcome to a new Unity 5 tutorial today, and this is going to be looking at the post-processing stack with Unity 5, and this is going to be a range of image effects which help you achieve more sort of stylistic effects to achieve something more towards AAA game development and help you make stuff almost look more realistic and add some sort of stylization in most cases. Now, the thing to understand about image effects is that they're something that you sort of you overlay over the top of your camera, and they're something that's done after, for the most cases, are done after everything else is rendered within your game. So everything after, you know, your graphics have been rendered, lighting and stuff like that, it will be done as an effect on each pixel of your game. So the higher the resolution of your game, the more impactful on performance each image effect will be. Most of these image effects are likely not suitable for mobile, but it's really up to you to sort of debug and work out which ones. I'll give some indication on how you can be more performant with some of these effects and which ones will likely work on mobile, and where you will likely see some dips if you put settings too high. So this is going to try and be the ultimate guide to teaching you how to understand using the post-processing stack and getting good quality out of your game. So what you can do to start off with is you can go straight to the Unity Asset Store, and if you go to the Asset Store and just search in post-processing, you need to make sure that you have Unity 5.6 and above. I think that's what's appropriate for these. You can get it from Unity's GitHub, and I can put a link in the description for that. Once you're on this page, you can click to download them, and once you've downloaded them, you can choose to import. So I will just click import, and I will port these straight into my project that I've got going on right now. And once you've downloaded your asset, the post-processing stack, you will see the post-processing folder being put into your project panel. And I've got a scene here from one of the ArcViz Pro packs, and this is a really cool scene to sort of just test out some of these image effects that we're going to use. So if you've got an FPS controller, say we're going to select the main camera, and there's a few things that we want to remember when we're going to use these things. You want to enable HDR if you're going to, aim for a PC game or a console game, and you want to disable the allow MSAA because we're going to do some anti-aliasing within the effects. We can also go to Edit, Project Settings, and Quality, and depending on your settings you've got, you want to disable the anti-aliasing up here so we don't have any anti-aliasing going on. So we can go back to our main camera, and with everything selected we can go add component, and we can start by typing in post, and we can add a post-processing behavior. Now we've got something in there. In our project panel we can right click, create, and choose post-processing profile. And this is going to be the item that we use to sort of control all the effects that we've got. So once that, we can just name that our post-processing V1 for version 1. And now we have that, we can go back on our main camera and just drag that new profile into our slot available on the camera. So now we never have to click back on the camera. And the thing to remember is the allow HDR just stands for high dynamic range, and it just allows the scene to reach colours in a colour space which is that it wouldn't normally have been able to reach, and some of the image effects will not render without that enabled. If we click back on post-processing version 1, we've got a whole host of different settings in the top corner. If I click the drop down on debug mode right at the top, you can see we've got a whole host of debug modes, and these are the things that we can see for quite a lot of the image effects. So let's make an example here, and we choose Ambient Occlusion, then we enable Ambient Occlusion. We can see that this is our debug mode, so we can see exactly what the Ambient Occlusion is doing, and without any of the other graphical effects or sort of materials and things that are in the scene, we can see exactly what it's affecting and how it's affecting it, so we can use these modes to understand what it's doing and how we can change it more easily. So I'm going to disable those for now and start at the top. Initial box of fog isn't very important. We'll first start with anti-aliasing, and if we open the anti-aliasing box and we tick the box, we will get a host of settings. So we'll get the method and we'll get a preset. I'm sure you've heard of anti-aliasing. If you imagine any object or any shadow when it's created in a game, if you imagine the likes of Minecraft, when you try and make a diagonal line out of squares, let's imagine, and imagine those are pixels, you'll never make a perfect line without it sort of looking jaggedy, and you need a way to be able to fill those gaps based on what the computer can calculate. So anti-aliasing tries to take those points and add points in between to just create the illusion of a smoothed out lines, so then you get rid of the jagged edges that you might get in shadows and in game. And there's two different methods. You can use the fast approximate, which might be more applicable to mobile, and that's much lower quality anti-aliasing, so it won't give you as good results. It's a lot more performant. And you have the preset mode, and you can choose what sort of quality. So you can choose to do extreme quality, and which will maybe bog down the game engine a little bit more, or you can choose to use the temporal anti-aliasing, which has a few settings, which is far more suited towards high-end PC or console development. Now, anti-aliasing can be a little weird one on the effects that it creates, but we've got a few settings, which we've got the jitter here, which is the spread. The higher we actually make it, the more accurate the actual result becomes, and the higher it becomes is the more impact it will have on your game, and the less actual impact it will have, and the less accurate results it may give. The sharpen at the bottom is as you do the anti-aliasing and it tries to sort of get rid of those jagged edges, you may lose some quality in some of the textures or some of the things that you try and use, and sharpen tries to sharpen up those edges, but it's all about fine-tuning things and sort of working out something that works well for you and works for your game, and it's really a thing to look at the profiler and see how it works for you. And anti-aliasing is a good thing if you get a lot of jagged edges. Again, we can look at the next one, which is called Ambient Occlusion, and you can see as I tick that on, you could see edges and between objects darken, and we again can use the Debug Mode at the top and choose Ambient Occlusion, and you can see how it affects things within the world. You can see that as light passes into objects that are very much close to each other or adjacent, the light passes into the objects, bounces around, and can't escape very easily. So it's much darker in places that are very much recessed, or things that would be very close to one another. And if you open up the ambient occlusion, you get a few different settings. So you can get an intensity, so you can make, add a multiplier and make it look far more intense, which is not always realistic. You can increase the radius, which adjusts where the actual ambient occlusion sits. So you could, if I take away the ambient occlusion, we can make it look like a very different stylized scene from what maybe we want for realism. We can choose to enable or disable downsampling, and if we enable downsampling, it will slightly decrease the quality of the ambient occlusion, but it will also save on a bit of performance. So unless you want something that's extremely specific on the ambient occlusion front, it's good to keep downsampling on, because it just skips certain pixels to be rendered, so will save you, maybe a lot of heartache down the line. And there's a few other settings for, depending on your render settings, so whether you're doing forward or deferred. And ambient only refers to if you're using deferred and a HDR camera, that it will try and make it more accurate based on that. And it will be taken into account when you do your lighting, rather than being a post-process at the end of the actual baking things out in the game. So we can move on to the next one, which is called the screen space reflections. And this is a pretty cool effect for making your scene look that little bit more towards realism, because we've got two examples. We've got additive and we've got the physically based, and additive is a much lower quality, easier on the performance wise, and it will take all the different areas of the game and it will decide, based on some calculations, what objects need to reflect in what areas. Whereas if we take, for example, our physically based, it will do a much more accurate job, do more checks to check the materials and the textures, and do a much more accurate sort of example of where and what the actual lighting reflection should be. And the screen space just means they will only do those reflections in what the camera's looking at any moment. So say you've got objects over this side that you can't see, it won't be doing any calculations for those reflections unless the camera's directly looking at it. But you've got to be careful that if, say, some objects are still taken into an account, say you've got something over here which is reflected in the floor down here, and it gets culled out if you look too far this way, you have to be careful, and you can tweak some settings, which is the screen edge mask, which will blur areas to try and avoid that area of things popping in and out of the reflections in the real time. And you've got a range of settings which can increase the blurs and the count to increase quality and such. There is a box here called reflect backface, and you can't really see it in my scene here apart from on this wall over here. Let's say we've got a mirror up here and we want to accurately reflect this lampshade up here. Sometimes if we don't tick this box, it will only do its calculations one way, but if we do the reflect back faces, it will do a much more accurate calculation to work out how it's supposed to be displayed sort of behind it. But again, this one's going to significantly affect performance because it's doing double the calculations on something that's already very performance intensive, and this is something that you can't use on mobile because it would just destroy performance completely. We can enable something called depth of field. And depth of field is just something that you'll see in photography and things like that. If you've ever taken a photo and you focused in on a particular object and say you wanted the background to be out of focus, so you can get more of a sort of stylized effect, so you can focus on the object in particular. If you want to make that stand out against the background, this is how you can achieve this. So we can use another debug mode at the top, and we can click the drop down and we choose the focus plane. You can see that everything that's in red will be completely in focus, and we can choose or tweak some of these settings to make it so that we can look at something different and make a sort of different look about it. So say we, for instance, wanted this back to a bit at the back here be very much in focus, and this sort of foreground here to be blurred, so we can sort of maybe have could be a cutscene over this side. We can decrease the aperture all the way down until we get to a point where we can just see our red debug over this side. And we can increase the focal length just so it encapsulates this area. And we can change the kernel size depending on what quality you're looking for. So the higher the quality, obviously the better the quality and the more it will impact on your game. We can get rid of the debug mode, and you can see now that very much so that only that in the very background is in focus and the rest is out, and you can just adjust and tweak settings depending on what desired effect you want to see. Motion blur is another similar thing, which is another one which can quite heavily impact performance because it will create a blur burst based on the motion that you have within your scene. So if I enable it, we can apply the motion blur, and it will blur the edges as we move with the camera. And we can use a debug mode to look at that, and we can choose motion vectors, and we can even increase the frame blending, which if we take it all the way down to the bottom, let's say, and we then test our game, you can see what the motion vectors do. It will give us an indication of where the motion blur is being applied based on these little arrows that are moving between the scene. But like I said, if we've got the frame blending all the way up, you can see that we can create a very distinct motion blur, which will sort of cause the effect of looking like your character might be drunk or something like that. The next effect that we do have is something called eye adaption. And this tries to simulate what your eye would do in real life. So say you went into a room or you looked outside towards the sun, your iris would close up to sort of not let as much light in because it doesn't require that light to actually be able to see properly. And similarly, if it was a dark room, say such as this, for instance, it would open the iris up more to receive more light so you can see more accurately. And you can use the eye adaption and adjust the ranges to try and get something more appropriate. Say if you have really bright areas, it will help you. I'll try and simulate this when we've got and enable bloom. So, like I said, the next one we've got is bloom. And you can't really see much change in the scene. And what bloom tries to sort of simulate is that in film and movies and when you use a camera, if they're looking at a very sort of bright area, you will see the sort of bleeding across other surfaces when you get a bright area. and can sort of give a pretty cool stylized effect, even when you just want to sort of emphasize lights and things like that. So you've got a few settings here, and you've got intensity, which will increase very much the brightness or the intensity of the actual bloom itself. You will increase the threshold, and it can blow out all the areas that you've got, and you can almost make it look like you're in another world, or it's an extremely sunny day compared to what we previously had. We can increase the intensity all the way, and it can almost look like you've got a nuclear explosion or something like that. So what we can do is leave it on maybe a realistic value that we quite like to look at. And you've got a slot at the bottom which is for a dirt texture, where you can make the lens or the camera look a little bit more dirty. And we can look in a folder in the post-processing called Textures and Lens Dirt, and we have some of these objects, and we can choose to go on the post-processing profile that we created and add a dirt texture to this, and you can see some sort of lens flares and dirt which would come off, and you can add different ones to sort of create different looks of, sort of aberrations on the screen. When we press play, you can see what I can see on the screen. You can see the dirt across the screen if you want to create maybe like a war game, or to look like that your player's seeing something in a dream, or let's say something like that. So say you've seen, the next one that we're going to use is color grading, and if we tick that, say you've seen you don't like the way it looks at the moment, and you don't like the color, you don't like how the light's affected over here. We start off and it's got a tone mapper which requires HDR on your camera, and the tone mapper just initially, if I set it to none, it will do no tone mapping to sort of try and neutralize the bright areas. And if I leave it on neutral, it will try and bring the areas down to more of a consistent value to make it more appropriate to use. And we've got a bunch of settings to sort of color correct all the exposures, the temperatures, and things like that. But one of the most important things, and the coolest things that you can use, is you can use the little trackballs, and you can make the scene look more towards a particular style that we're going for. So say we wanted this room to look more, say, bright and sunny, instead of just being default and looking a little bit grey, we can move it towards maybe oranges and yellows with the initial trackball. Do the same with the other. And what we can do is adjust things like temperature, so you can make it more towards a cold or a warm temperature. You can adjust the tint of the overall scene. You can decrease the saturation, so say you want to go to an entirely black and white scene, or you wanted to go something which was really saturated and looks bright, then you can choose to do that, so it makes everything really nice and colourful. And you can choose to increase or decrease contrast for an entire scene. And we can choose to adjust the entire exposure for the scene, so if we say we wanted to make it look far more brighter than we previously did. We've got another setting which is called Use a Lookup Table, and this is something where it just uses a texture. So if we took a screenshot of this game now, applied similar settings to this with color correction and the grading, brought into a program like Photoshop, did those sort of similar tweaks, we could then bring the texture back into here, and without it having to do the color grading, it could refer to that texture or that photo that we just made based on the settings. So say you wanted these greens to look like this, the quality to look like this sort of thing. It will look at this user lookup and go, yep, and do the settings without you having to use the other post-processing. So it can almost be a little bit quicker than you would have normally thought that it would. So it'd be, again, slightly more optimized. We've got another thing called chromatic aberration, and this is something that you would see in a lot of games trying to simulate it with a broken camera. Games probably like Outlast and things like that. So you will see a sort of, if you look down towards this bottom and increase the chromatic aberration, you'll see the sort of red, green, blue sort of banding that we get, and that's to sort of simulate the look of what an old-fashioned camera or a lens would sort of associate. And you can often sometimes see that if you wear sort of glasses, because that's a similar sort of sometimes if you wear a strong lens, and you can create this to make it look like, as I say, a broken camera or something slightly more stylized. And you can use spectral lookup textures to sort of increase or change different looks towards your scene. So that's more one that you probably want to use more sparingly, because it's quite a sort of effect that looks quite annoying if you use it too much. We can enable something called grain, and as you might think, if we increase the intensity, it will add grain all the way over the screen, and if we decrease the luminance and increase the size, we can get, as you can see, a lot of grain there, and you can choose whether it's coloured or not if you wanted to create some grain for maybe an old-fashioned movie or something like that. Then you have a cool little effect called vignette, and it will darken the very corners of your screen, because screens or cameras and things like that in real life, lenses are not square as you would a computer. So a vignette just allows you to sort of simulate this with a just a sort of simple area, and you can choose what type of mode you want, whether it's classic or masked. And you can choose to set a colour if you don't like the vignette being black. You could choose to increase the intensity, so you can almost maybe look like the character might be blinking. You can increase or decrease the smoothness, choose how round the actual vignette is, so you can make it more square if you're going for that sort of look. And you can choose to truly make it a sphere rather than just more of an oval. But if we pull it more towards black, you can see it like that. The intensity back, so we can get it more like so, so it softens the edge more easily. And the last object at the bottom is not really apparent for this. So as I say, it's just a case of looking at a bunch of these image effects, applying them, and deciding which ones work for you and which ones will add a sort of more step towards realism for your game. Because a bloom is always a nice one, the screen space reflections, if that's something that you can support on high-end and thing. You can choose the colour grading to try and make your scene suitable to a more interesting look. So I'll just quickly go back to where we were at the beginning before we applied any image effects, so you can see what happened. So remember, the anti-aliasing smooths out jagged areas, and this is more one for a console. You'll need it for VR, and it might be applicable for mobile if you use the fast approximate. Use the ambient occlusion to darken areas to make things look more towards real life. If you adjust the settings, it might be suitable for mobile. You can use the screen space ray trace reflections, which is good for high-end because it will create the illusion of things reflected realistically in screen space rather than doing it for everything in the scene. You can use depth of field if you want to blur certain areas to sort of make it focus on something in particular. You can use motion blur to simulate a drunkenness or blur out edges as you're moving, which probably neither of those are probably great for mobile. You can use the eye adaption to bring a scene more towards real life, so your eye adjusts according to the values in which you see in your scene. You can use bloom to make the bright areas sort of bleed across others, and depending on what you're going for, you can use the colour grading to bring it towards a colour that you're looking to achieve. You can use the user lookup table if that's something you're interested in, and you can have a few examples at the bottom here in the neutral lookup. You can use a chromatic aberration if you choose to want the effect of a sort of old-fashioned camera, or something which is more towards a camera lens. You can choose grain if you want to have more of an old-fashioned look to your scene. You can use the vignette to darken very much areas of your scene if you choose to use that. And like I said, I will enable the eye adaption to allow it to sort of more accurately bring down the very hard or harsh sort of blown out areas and make your eye need to take in less light to sort of see these areas. So all in all, you can go from a fairly modest scene to adding a whole host of extra detail to things that would take a lot of extra effort if you couldn't use these image effects on this post-processing stack. So all in all, it's a case of you looking at your stats and your profiler to see which things affect you the most, and judging from there. So hopefully this sort of helped you get an understanding of the ways that you can optimize for using the post-processing stack and how you can achieve better quality within your games. So thanks very much for watching. Don't forget to like, comment and subscribe. Cheers.